Okay, so these are the actual segment notes. Yours are green, but we have to be able to create similar triangles because the only way that we've found segments so far this year is by using trig, by using Pythagorean theorem, and by using similar triangles, the proportions from them. So those are the only three methods that we have learned to find side lengths. So we're going to be using the same thing. There's also some circle properties that you do need to know. So the first one, two basic ones that have to do with tangents. If they give you two tangents from the same point are going to be congruent to each other. So anytime I have two tangents that come from the same point, those two segments will be congruent to each other. That's kind of a hard fact that you have to know. All right. I could do a congruent triangle proof and show you that, but these two tangents are always going to be congruent to each other. This comes back to the tangent and the radius that we've been using it to find angle measures, but I also could use it to find side lengths, to find Pythagorean theorem, or possibly do trig even. So, anytime I have a 90-degree angle, I have a right triangle, I can do trig. The next couple ones are different. If I have two chords again stay within the circle, they intersect. If I want to find one of these pieces, what I have to do is create some similar right triangles. And there's two ways that you can connect them, but what you're doing is you're connecting the points that are on the circle. So I could connect C to E, for example. That would give me this triangle here. And I could connect B to D. That would give me that triangle there. Now, I know that angle G has to be congruent to angle CGB, has to be congruent to angle BGD because of vertical angles. So I would set those up first. And then I also know, because we've been studying angles, that angle B and angle C have to be congruent to each other because they're both half of this arc. So I would line C up and B up, and then I would have E, and then I would have D. So I go with a vertical angle and then an inscribed angle. So I start with the vertical angle, then I do the inscribed angle. And the other one is inscribed also. These are opening up to the same arc as well. So it doesn't really matter what one you do. But from there, you would set up your proportions, just like we've been doing, and you'd substitute in and you'd solve. All right? The two chords is the easiest one, I believe. Sometimes you might have to draw the circle. You might have to draw the circle and you might have to draw the two chords. Two secants, I think, is the next easiest one. So what I'm saying is that if you connect a secant and a chord, you're always going to get a triangle. So I have a secant, and what I'm going to do is I'm going to take the end of that secant and I'm going to connect this chord, again, just like we've been doing. And so I always start with the outside angle. And then I go to the inscribed angle. So my outside angle is A. My inscribed angle is C. And then the third angle in this triangle is D. Then I go and I connect the other end of the other secant to the chord. So now I'm still looking at the same triangle here. This one's a little bit different. So here's this triangle here that I'm working with now. But I have my outside angle, I have my inscribed angle, I didn't mean to put a comma there, and then I have my angle B, the third angle that makes that triangle. I know that C and E are congruent to each other because they're both intercepting arc BD. So I'm setting up the inscribed angles that open up to the same arc. And from there, I'd have my proportions. So again, the only way that you can solve some of these problems, unless there's tangents involved with the two tangents, is to use proportions. The tangent and the secant, I think, is a little harder. So what I'm saying is that the tangent and the secant, and if you connect the tangent to the chord, tangent to the secant, connect the tangent to the secant. So we're going to connect them. That gives you one triangle. Again, I'm going to start with my outside, and then I'm going to go to my inscribed. So my outside angle is H, my inscribed is J, the third one is K. Now the next one is you connect your tangent and a chord. So tangent and a chord looks like this. So what you're going to do again is you're going to go your outside, but then you're going to go to your tangent point, and then that third angle. So that's outside, and that's the tangent point, the point of tangency. So I go outside, tangent point, and then the third angle, because I know that K is half of this arc, and I know that J is half of that arc. So I know that those angles have to be congruent. Okay, so how does this play out? An example. So in this circle, we've been given two chords. They want us to find DE, so I call DE X. I can set up triangles either way I want. I'm just going to go from C to A, and I'm going to go from B to D. So I set up triangle E and triangle E because again I have vertical angles. And then I go C and B because those are inscribed and they open to the same arc. So ECA and EBD. Then I have EC over EB, CA over BD, and EA over ED. Okay, now I'm just substituting in. Okay, so I'm not going to go through that one. You substitute in and you solve it. Two secants. So let's label this first. PR is 23, or 32, sorry. And these are not drawn to scale. These are terrible diagrams. QR is 27. PT is 20. And I want to find PS, so I call it X. So I do one secant at a time. Secant and chord. So I go outside, inscribed, and then the other remaining angle. Then I make my other one. I go outside, inscribed, remaining one. So I set up PR, PT, RS corresponds with TQ, PS corresponds with PQ. So PR is 32, PT is 20, RS I don't know, TQ I don't know, PS is X, and PQ 32 minus 27 is 5, so that's not X. And I can solve from there. Last one. Now I have a tangent in a secant. CB is 9, PB is 3. They want to find PA. So again, I connect my secant and my tangent first. So triangle P, inscribed A. Then I go to the point of tangency. So P, point of tangency, B. So I'm looking at PC over PA. CA corresponds with AB, and PA corresponds with PB. PC is 12, PA is X, PA is X, PB is 3, and I would solve that. So that's your 3 different methods of solving using proportions. You have to be very careful that you're lining up the right angles.